Hello, everyone, and thank you for joining us on this video probe care and RVI task proficiency session. I am Paul Thompson with Waygate Technologies Visual Business, and I'm the Global Manager for Training and Technical Support. Today, I'm also joined by two of my colleagues, Tom Britton, and you'll find his bio on the speakers panel, and also Tom Ward. So both of these gentlemen and I have worked together for 20 years or more. Mr. Ward's been in the remote visual business for 30-something years, and very similar story with Mr. Britton. So they're going to help me with moderating the questions and answers as they come in, and then we'll have a live session to address those questions and answers at the end of the presentation. So before I go further, I want to make sure that I cover a few housekeeping items. You'll see at the bottom of your screen, there's multiple applications that you can turn on, and you can also use the bottom right corner to drag the page to whatever size you want. You can reposition it on the screen to make sure that you have the best viewing experience on your desktop. The materials that are going to be presented today in the slides are going to be available for download. You'll see a resources panel, and make sure that you take a look at that material and download or link to the information to download. Also, if you have any questions during the webcast, you can submit them through the Q&A engagement tool. You'll see that link at the bottom of your screen to bring up the Q&A panel. And we'll try to answer all your questions during the webcast, but if a fuller answer is needed, or if we run out of time, we will answer your questions later via an email. Unless you post a phone number, we'd also be happy to call you. You'd have to just put that in the chat whenever you're posting your question if you want a verbal callback. And so we keep track of all these questions so that we can make sure and get back with you and provide the information you've requested. Then at the end of the broadcast, you'll see a couple of tools where you can ask to book a meeting with one of my colleagues or have a virtual demo on your virtual settings there in your office. So just click on the engagement tools and add your information and make your request. So with that, I'm going to get started and talk about RVI care and also the tasks that are commonly done. And when I say care, it's how do I take care of an asset that I've just invested significant resources in so that I get good life out of it and get the best results possible. So just a brief historical update so that you know who we are. And when I said I'm with Waygate Technologies, you know, our business started actually back in 1914, but Welch Allen made the world's first video borescope in October of 1978. And then through a series of channel partners and mergers and acquisitions between VIT and Everest Imaging, we became Everest VIT, became so successful that General Electric wanted us to be a part of the team. We came into that fold in 2005. We ended up in the oil and gas group with Baker Hughes, a GE company. And then that was then sold off from GE, and we're now fully a Baker Hughes business. That happened in January of this year, actually. So we're new to the Baker Hughes family. And when we look at what is in the portfolio that you may use when you're doing a remote visual inspection, you know, it covers everything from a 0.4 millimeter optical instrument that you look through with your eye into the video borescope family there in the middle. That's where we're going to be spending today primarily. But we also have tools that you can, say, from a manway, look inside of a vessel, or from the ground, look up at potential damage on a horizontal stabilizer on an aircraft that's 30 feet off the ground. And then we also have people that show up in a van and come on site with you and do the work with you or for you. And all of this is captured in the digital twin, and the software solutions are kept track of through a couple of different platforms that we have. But today, where we're going is I want to talk about historically with some of these video borescopes that you may be familiar with. We started with the XLG3. It was large and it was powerful, had a lot of light, had interchangeable probes, but people wanted something more portable, so we launched the XL Go, and then people said, well, we like the Go, but geez, that XLG3 had interchangeable probes. It had a lot of capability. So we rolled out the Mentor Visual IQ in 2014. Very powerful tool, touchscreen interface. That's what I'm going to be spending my time on at the end of the session, showing you a little bit of functionality. And then in 2018, we released a Flame handset, and we have just announced that we're rolling out a new software update for this Flame colored handset. So get in sync with my story here. Just a storyboard of what's out there today in the world of portability and also versatility and capability. The two platforms that I am going to be referring to are this XL family of tools and also the Mentor Visual. I will be using an analyze probe later today. And when you look at what's in those kits, there's a carry-on, there's a portable case that you can put in the overhead of a aircraft if you're going around the world somewhere, or a shop floor workstation case. That's one configuration. Then on the more portable system, there's also a carry-on workstation case that's available for those. It's a compact dual probe case, so you can find out more about those from our website and from the literature. I just wanted to give you an overview of what I'm going to be spending time on today. When you're looking at the Mentor Visual and you're looking at doing your job, there are a number of probe lengths and diameters that are available, and some of those tools actually allow you to put working tools to retrieve FOD or to hook onto a turbine blade, pull the scope around the internal part of the engine so that you can do a full circumferential inspection. So various tools to do your job, and that's why we have that workstation and the compact dual probe, because some people actually roll out with a 6.1 millimeter and an 8.4 or a 4 millimeter. So they'll have two different probes to do your job fully in the kit. So when I'm talking about doing your job, I'm curious to know, when you go out to do a bore scope inspection, can you just give me an idea of what are some of your typical bore scope inspection tasks, just so I can get a feel for what's important to you when I'm talking about the actual live presentation earlier? Are you doing pipes and vessels around chemical plants, refineries? Are you doing wind gearbox or pulp and paper mill gearboxes? Working on jet engines or aeroderivative boilers and heat recovery steam generators or large gas turbines? Just trying to get a feel for what's important to you. Just take a second for you to look at those and let us know what you see there. Still see that the results are clicking up, so I'm going to wait just another minute so everybody has a chance to let me know what's important to you that you're doing regularly. Okay, so as they're still coming online, it looks like there's a mixed audience. A lot of people doing a lot of different kinds of inspections, and believe it or not, rotating machinery, whether it's in jet engines on wing or jet engines on skids where they're generating electricity or injecting CO2 for compression. Those jet engines have a wide variety of applications, as do the large gas turbines. So yeah, thanks for sharing that with me. It helps me think through some of the live images that we'll show here in a little bit. So you've made an investment in a video borescope, and it's a significant investment. And what I'd like to talk about is how to protect that investment by cleaning it and protecting it. So in the world of video probe construction, I think it helps to understand what's behind the curtain, whether it's a small diameter 3.9 millimeter scope or a larger diameter 8.4. Internally, you have to have light. So it comes to a fiber optic bundle. It goes through the optical tip adapters and shines on the scene. So that image can then be, or the scene can then be illuminated and the light come back into your CCD imager, okay? Okay, so lighting and imaging, great, but that's not the whole story. The other thing that's sitting back there are optical tip adapters, and these optical tip adapters have multiple components. They're assembled by hand. They're precision optical lenses, much like you would find on a high-end Canon or Nikon or those kinds of cameras. And these optical tip adapters allow the camera to have a highly focused image come into the camera so that you can see it on your screen. And they also allow you to do a number of things. These bodies that are at the top have forward viewing and side viewing lenses. And then the thimble is that bottom threaded part. Okay, and you're saying, okay, Thompson, why are you talking to me about those? People sometimes forget to clean them every time they put them on and take them off of a scope, and that's one of the high wear areas. I'll show you a picture of these thimbles in a magnified scene in a moment, but the thing I want you to take away from that, it's a significant investment, and if you take care of them, they have lasted 20 years or more. I've just seen it happen. And I've seen people wear them out over a course of a few months because they didn't clean the oil and sand out of those threads. So these optical tip adapters increase your versatility in the inspection so that you can look at multiple scenes with the same camera. They'll change the field of view, the depth of field, and also the direction of view, whether it's forward or side. And with the right optical tip adapter installed on the camera, these various lenses that you're looking at on the bottom of the page, the bottom left one is a 3D phase measuring lens. It will project a series of fringe patterns or shadows on a scene and very precisely and accurately be able to generate a point cloud. And you may be asking, okay, what is a point cloud? Well, join me for the series on real 3D measuring, where I'll be going into a deep dive on how to be the person that gets the very best results and not be the person that rejects $1.5 million turbine engine by making a bad call. So we'll talk about that. But if you look at the picture of the lenslet laying on its side, there's a white bar up at about 2 and 3 o'clock. That little white bar is holding micro pins, pogo pins, if you will, to provide power to those 3D phase generators. And then just outside around the perimeter, you see the threads that are holding that optical tip adapter onto the camera. So we're talking about lenses in some cases that have an OD of 4 millimeters or 3.9 millimeters. So cleaning them is paramount and taking care of them properly. So from there, let's talk about how the probe itself is constructed. There's a lot going on in there. You can see inside of that 4 millimeters, there's going to be 4 cables for pulling the camera up, down, left, right. There's going to be a supporting monocoil. There's going to be an outer layer of tungsten braid. All of this goes out to the end of the insertion tube where the bending neck is bonded onto it. And there's a series of beryllium copper wattle washers that allow the camera to articulate. And not only that, there is also lighting and camera action. So a lot going on inside of that. We've been making these things, like I said, since 1978, make some of the most durable borescopes in the world. And I regret to say that accidents happen, or people intentionally abuse the instrument to get results in places where they may not have been able to get them before. Meaning, maybe they'll put them into an area where there's an elevated radiation. The camera will work, and then it will fail. And in those matter of moments or minutes where they capture data, they can save themselves millions of dollars at a nuclear reactor. Or maybe you're feeding that same insertion tube inside of a turbine engine, and it's wearing over time. So wear and tear does happen, but there's ways to mitigate that or minimize it. Let's talk about first the cleaning component. You remember the small micro pins that I showed you in the back of the 3D phase lens? There's also an O-ring in there. And if you put a tip of your shirt or a rag or a big Q-tip in there and spin it, you're going to spin those electrical contacts right out of the back of the tip adapter, and it is not a happy ending. So what you want to use are the micro swabs on the left-hand side. They're available in this kit. We don't manufacture these. We just buy them and put them together in a kit. So use alcohol, use micro wipes, whether you get them from us in an XA Clean kit or you get them from a high-end camera store. The bottom line is you want to use the right tool, and you'll see that I'll talk about doing this under magnification here in a moment. So when you're cleaning this, you're going to be looking at the joints on the bending neck. On the left-hand side, you're going to be checking it for fraying. You're going to be checking it for any kind of damage. You're going to be wiping them down with alcohol, is what the manual calls for, a 70% isopropyl. I like to think about it this way. What is the least aggressive thing that I can do to clean the tool? If I can use a soft, clean, lint-free cloth and get it completely clean, great. If I need to get more aggressive, use clean water on that same cloth. And then, if needed, go to the alcohol and water solution. And make sure when you're wiping that down, like the hand is showing in the right-hand side, feel for any kinds of kinks or dents or any kind of anomalies, and have a discussion with your coworker or your manager to point it out and determine, this is the analogy, do I need to change the oil? In other words, do I need to do some preventive maintenance before it gets worse? And from there, you continue inspecting the shaft. You look at the optical tip adapters. On the optical tip adapters, the distal lens is that lens that you see when it's threaded on the camera. It's that lens that's on the leading edge of an optical tip adapter. And when you remove that OTA from the camera also has a distal lens out on the end. Those are the two lenses you want to clean. And then you want to clean all of the threads around the camera, and you want to clean all of the threads inside the tip adapters. And when you're doing that, folks, please do it under some kind of magnification so you're not, A, bending or damaging the pogo pins on phase tip optics, or B, you're not digging out and removing the O-rings that are inside of that proximal body of the OTAs. So just some thoughts around that. And when we're talking about cleaning this, you're going to be using alcohol and water because you may have gotten some products on there. The question often comes up, well, can I use this in oil? Can I use this in various products? The first caveat I want to make sure everybody is excessively clear on is this system is not explosion proof and it is not intrinsically safe. So when you look in the operator's manual, in this case, this manual has Appendix Charlie for chemical compatibility, you'll see a lot of things that are hydrocarbons and do have a flash point that could ignite or combust with an ignition source. And so while we have tested it in avgas and jet fuel and a number of products, the system was inert, the system was turned off and de-energized. It was simply the insertion tube was laid in those products for 24 hours. It was then removed and cleaned in the way I just described, cleaning it with a cloth in water, or a cloth with alcohol. And then it was returned to service with no noticeable damage to that insertion tube material. Again, when you're cleaning these optical tip adapters, here's a picture of what I was talking about, those pins. And I'll show you a bigger picture here because we've just talked about using the proper cleaning kit. Let me show you what the inside of that body looks like. When you're looking at the proximal body of a 6.1 millimeter, keep in mind this lens body, when you're looking at that backside, the ID is less than 6 millimeters because of the thickness of the material. You have on the lower left the threads that are in the thimble. And then the proximal lens is that window in the middle that lets the light come into the camera, and the light is going out through the light cane. Well, that light intensity is so significant that we realize we are putting out so much light, as a matter of fact, more light than most video borescopes, if not any on the market today. That light is spilling into the video path. So we created a light dam, if you will, with an O-ring. And folks, since this is a live presentation, Tina or somebody on the call, can you send a link to Alexa? She's trying to get into the meeting. Sorry for the interruption, but I want to make sure that she's able to get in. And then on the bottom right, there are pogo pins. Those are the ones you want to make sure that you're not spinning off and damaging. So this is done under magnification. You're cleaning the proximal body of the lens only when needed. In other words, maybe you have a blurry image and your O-ring is still intact. Just simply clean the middle of that proximal window. Okay. So other preventive maintenance that you can consider is to look at the entire shaft, meaning the insertion tube, the bending neck, and the camera, and look to see if there's any fraying. You know, in the picture you're looking at here on the bottom, this is something that tends to happen on what's called an enhanced borescope inspection or an enhanced BSI. Or I've seen people feed the camera in around 1 or 2 stages in a compressor section. The edges of the blade are very sharp, and they just shove it in and out. And if you listen to it, you're going to hear it grinding. Versus gently rotating it back and forth, wiggling it in, and letting the crosshatch of the braid walk you in there. So you can cause premature wear by not paying attention to how you're pushing the camera across sharp sections. And, you know, this is an area that will wear over time, and to get that braid and sheath changed is something that you'll want to do before it causes larger problems. Larger problems meaning if that bending neck becomes separated. I've seen people put electrical tape on them. I've seen them do a lot of unusual things, and then they put it into a work area, and the tape or this braiding gets bunched up, and you can't get the camera out of the inspection area. People have called our people to show up in a van and retrieve those cameras for them so that they can actually get that asset back online and get their camera back out and repaired. So over the last 20 years, these kind of things do happen. Damage does occur. And so you'll be seeing more information on a visual care and a visual care plus plan where these kinds of tune-ups are available under those plans. So stay tuned for some information from one of my colleagues, Daniela Escobar, on that.
Hey, Paul, this is Tom. I just had a question came in, if you could just respond to it. Just again, relative to damaging the probe and potentially cleaning it using incorrect chemicals. Could you just address how we join together our probe and why using aggressive chemicals could be a risk?
Tom, I think that is a great idea, and I'll address it now, but also I'll get more thorough, address it more thoroughly in about 2 slides. But so what Tom is referring to, if you're looking at my screen right now, I'm showing you on the left-hand side an insertion tube with what one might think of as a minor kink. Well, that braiding that you're seeing is a tungsten braid, and it is impregnated with polyurethane, and that is what creates the water tightness. In other words, this allows you to drop this assembly into 1 atmosphere or 30 feet of water, and it is watertight. We tested at the factory that way. These quote-unquote minor kinks will break down the polyurethane in some cases, and liquid can ingress there, migrate down the path of the insertion tube internally, and then cause failures of the camera because the camera now has liquid inside of them. And Tom, I know you're asking about cleaning, so I just want to show you the picture on the right and finish that thought. If you get a kink that's bad enough that the probe will bend, you see down there on the right-hand image, there is a ferrule that's welded on not welded on, it's crimped on, and it's crimped on over an epoxy bond. So degreasers, stoddard cleaner, harsh chemicals will cause those epoxy bonds to break down. But damage, like you're seeing just to the left of that ferrule, if you can gently take the insertion tube and into its normal radius, if you see it start collapsing on itself, it then starts acting like a guillotine, and it's cutting into the crushed. Inside there are stainless steel monocoils. That stainless steel monocoil is crushing the internal camera harness and or the internal light harness, and or it's crushing the articulation cables. And so, Tom, to that question that was asked, on the right of that ferrule, there's some mesh that allows the articulation to happen more fluidly. And inside of that is a rubber Viton sleeve. So if you ever put one of these cameras in some SkyDraw, you're going to see it melt in front of your eyes over a matter of a few minutes. The epoxy will deteriorate, the rubber Viton will swell, and you've just bought yourself some grief because it is going to come back to us for a rebuild. And that's the good news. We can repair those and rebuild them, but SkyDraw and other cleaners like that are really detrimental to this. So, Tom, I'm going to talk about cleaning in just another moment. And what I would like to do first, though, is to just get a little more information about what is the most difficult thing that you guys are doing. These are the kind of things that our scopes are used in, like in weld analysis or erosion corrosion. But that also means you have to sometimes feed the camera through multiple bends, wear points, things like that, long curved pipe runs. So if you can just give me a sense for what you're doing the most of. Are you doing post-inspection image management and video handling? Are you sitting on the back end in a QA role? Just what are you doing that is the most difficult part of the BSI task for you? I'll give it just another moment here. I see the poll is clocking up, and after it settles just for a second, I'm going to let you guys look at what our friends and colleagues on the call are doing. And these tight paths through multiple stages of a blade, those are the ones that are absolutely the most difficult for the exterior wear and tear on the insertion tube, on those epoxy bond joints, on the braided sheet. And just think about walking the camera in place by gently rotating it left, right, giving a rotational axis as you're gently pushing the camera into place, because what that's going to do is help it walk across the braid. Try it sometime and listen to the camera. When you're pushing it in, you'll hear it grinding if you don't twist it. And as you gently twist it, you won't hear that grinding. So just some things to keep in mind there. Then one other thing that is very obvious is there are lubricants in the wind turbine business and other gearboxes that are not easily cleaned by alcohol. And what we found is if you use some common off-the-shelf dish soap, not detergent, not part cleaner, not degreaser, stoddard cleaner, MEK, or anything like that, use a couple of drops of soap in a cup of water and wash the dishes. What you're doing is you're cleaning those oils off of the surfaces. Be cautious and mindful about O-rings and 3D phase measurement pins. And this is just like washing dishes. We wash it with soapy water, we rinse it with clean water, and we air dry them. So people have asked, well, can I clean them with a keyboard cleaner, a can of keyboard air? Sure. Just don't stick the nozzle in the backside of the tip, push the trigger, and that air pressure is going to blow the O-ring out. Hold separation between the tip of that nozzle and the back of the optical tip adapter and air dry it. You'll find in the resources a care use checklist. Feel free to take it, make it your own. This is all about what I call keeping it cool, keeping it clean, and using finesse. You cook a camera in a warm turbine, you just bought a new camera. It's not fun. If you keep it clean, you won't wear out the threads on the camera or on the optical tip adapters, or inversely, I've seen cameras come back from sandy regions and they're doing turbine inspections, and that oil and that sand are embedded in the threads, and it's so bad you can't even get the camera, the optical tip adapter off of the camera if they haven't worn the threads out before then. And the whole use finesse piece is, don't crush it by running over it with a work stand. Don't close the car door on it. Don't get in a hurry on Friday night, close the lid on it. Those are all the things that we get cameras back for because they haven't been kept cool, they haven't been kept clean, and the user doesn't understand what finesse means when it comes to using the borescope. So it's a 2-page checklist. Feel free to make it yours. And I'm going to move on now to just some general safety precautions when you're using a video borescope. And you can read these. They came straight out of the manual. The bottom line is that insertion tube is conductive. Don't get it in touch with live voltage sources. That insertion tube, if it fails, can be an ignition source. This system is not intrinsically safe, nor is it explosion proof. A general best practice is to use what we call home, which is going to return the camera back to a straightaway orientation. Use that before you extract the camera, because if not, you have the cane handle, the tip articulated over in like a J configuration, and you pull that camera out of the work area, you are going to, there's just no doubt about it, you're going to stretch cables, you're going to wear out bending necks, and you're going to cause premature failure, because that is not what I call finesse, is leaving the camera locked and pulling it out of a work area while it's locked. So straight out of the manual, just some basic things that can help you when you're out on the job. Then I just want to show you this one picture of configuration. This is one example. We have a number of cases. And when I say cases, I'm talking about shipping and storage cases. And putting things back in their proper place is going to allow you to store and ship the system in a way that's going to protect it from harm, okay? And if you look at that little caution window, it's telling you to make sure that you have an optical tip or a head guard on. What that's going to do, it's going to prevent, it's called prevent damage to the tip attachment mechanism, better known as threads. So always have something on the camera. Don't work with the system, even though it will give you a great picture without an optical tip adapter or the head guard installed. Make sure something is on the camera before you use it in a workspace. And then before you store the system and put it in this case, make sure you have a head guard installed on the camera. I've had people say, now, why is that important? So let's think about that. We put the system away. It has a 3D phase measuring tip on there, or any of our optical tips besides the head guard. And they have an O-ring in the proximal body to keep light out. Well, if an O-ring stays in compression, it gets hot, it gets cold, sits on the shelf for a few months, that O-ring is going to go into compression, and you're going to start seeing at some point an image that looks like it's milked out or it has white, and it's really an indication that even though the O-ring is installed, that you have abused that O-ring by keeping it in compression and in storage and in hot-cold situations. So that's why you want to keep this head guard on the camera when you're using it or in storage. So what you're seeing now, or should be seeing now, is an overview of the layout of the face and user interface on this particular video probe system. It is the Mentor Visual IQ. So orientate yourself with that, become familiar with your kit. If you have any questions on what's in there and what each function for, reach out to one of your sales professionals. Reach out to me. Let's talk about making this meaningful and useful to you. And these are the interfaces I'm going to be using here in just a moment. First, I'd like to just ask you again another question. When you're performing remote visual inspections, what are the common tasks that you wish were easier and that you wish were faster? And we use this kind of feedback to help us think about, what do we do on the next great product? Do we include something that makes your job or your task easier? If you'll just click on the poll questions for that, I would appreciate it. So they're rolling in. I am going to click over and show you what I see coming in here. As you might expect, knowing what you're looking at and how to get to what you're looking at and how to orient the image so that when you send that picture to an inspector, an engineer, a customer that's going to review that image, it's actually going to look meaningful to them also, okay? So with that, I'm now going to switch over and show you a few things live on the screen. And Tom Britton and Tom Ward have been watching the chat questions. Tom, either one of you, is there anything I should focus on first? Because I'd planned on talking about how to annotate an image, how to save a quick digital video recording, how to rotate image overlays to that last poll question. People were understanding how to get orientation.
No, Paul, I think that sounds great. There are a couple of questions coming through, but I think it makes sense to related to the care and maintenance, but I think we maybe save those till the end.
Okay, and Tom Britton, I think you were going to share something also.
Yeah, just because you were talking about the oil capabilities and the waterproofness, there was one question about, is the probe oil damp resistant? And if you could just restate the waterproof capability and oil proof capability.
Yes, Tom, great question, and thanks for asking that, whoever posted that. So if you're holding one of our video borescopes in your hand, because the display and the probe are integral on our kits today, coming off of the back of the display is a torsional strain relief. It allows you to rotate the insertion tube 90 degrees one way or the other without damaging that mechanical interface of the shaft to the body. From that shaft at that point, meaning the insertion tube part of the shaft, all the way out to the distal end where the camera is on the shaft, you have three pieces. You have the insertion tube, the bending neck, and the camera. All three of those components, when they're sealed together and working properly, are considered IP65, meaning the ingress protection against dust is at 6, and against moisture and water is a 5, and it is also watertight and tested to 14.7 PSI, or 1 bar, meaning that you could drop that camera in 33 feet of standing water, okay? Meaning a column of water 30 feet deep. That's why some submariners take our camera off the side of a dock, go down to the bottom of a prop shaft, and insert the camera in there and look at bearings. It's because that entire assembly is sealed, okay? That's water. You start talking about oils, and not all oils are created equally. Inhibited transformer oil, like in an electrical transformer, I've inserted the camera and submersed the whole thing in that inhibited transformer oil. You can see severely clearly through that oil. Motor oil on your car, lubricants on turbine engines. The one oil I'm very familiar with is a hydraulic oil that is called Skydrol. It is a vegetable-based hydraulic fluid, and because it's vegetable-based, the preservatives in it are, let's call it, aggressive. They will just eat that entire shaft up, the polyurethane, the Viton rubber, the epoxy bonds. And so if you look at the list in the chemical compatibility table that is in the presentation here or in your manuals, you'll see what we've placed it in. And the caveat to that, again, is that the system is not considered intrinsically safe nor explosion proof when it's energized. So I hope that answered the question on that. And if not, just post another follow-up question or comment on that, and we'll talk about it some more. So, Tom Britton, I heard you last. Are you seeing my screen with some metallic objects in the front of it?
No, I see a live demonstration cover page.
Okay. And let me just go back and change my screen share functionality. It worked earlier. I'm counting on it working now. When I click share,
still got a PowerPoint cover.
What are you seeing?
Slide there. live demonstration cover page.
Well, that's not any fun, so I'm going to just something. Try it one more time. I'm doing a screen share. I'm sharing my monitor with a live video display, and I'm clicking on, let me try sharing the application, Tom. I'm just clicked on share the application. What are you seeing?
Maybe someone on the viewing side has seen something different, Paul? I'm on the presenter side.
Okay. Would somebody just chat to the questions if you're seeing a live display of a turbine blade and a 3/4 pipe in the background? That's the beauty of live television, right? And Tom, will you look in the chats and see if somebody's telling us what they see?
Yeah, I'm not getting any chat input yet.
No one's seeing anything yet, Paul.
If any of my colleagues are on team, will you chat what you're seeing in the team chat to me directly, please? Tom, I know it worked. We had it working beforehand. I think if you're still seeing my live demonstration, I'm still streaming. So now I'm just re-engaging it one more time and looking for somebody to confirm via a team chat if they're seeing a Visual IQ live screen. And Tom, if you don't have one, I'm going to talk through what I'm doing. We are not seeing anything. That's very interesting. So Gina, I don't have any answers to that magic. And so with that, I'm going to leave it on sharing just in case it does come up. And Dennis or Jessica, they're both telling me they're not seeing it. Tom, let's go to questions that are currently posted and see if this thing comes to live here in a minute. What questions are out there for us to talk to?
So there was a follow-on question about repair. I know you introduced earlier the concept that we have repairs and we had some new programs. The question was specifically, when there's damage, is there a flat rate for a repair?
You know, different regions around the world, we have service centers in Europe and Russia and Singapore, around the world. They have regional pricing models that are best for that region. I can speak very specifically to North America, where there are two different models of getting your repairs done. There is a tiered pricing level, meaning in the tier 1, we repair anything that's wrong with the system except replace the camera or replace the insertion tube shaft. Then there's another tier that will replace either one of those, camera or shaft, and take care of everything else that's wrong with the system. That's a tier 2. And then a tier 3, let's just hope you haven't cut your insertion tube off. The camera's still inside of a turbine, but we'll replace the camera and the insertion tube and the anything that's wrong with the control system. We'll replace and repair anything that is wrong with the system on a tier 3 repair. That's in North America. Or you can say, I just want you to look at it and tell me what the repair is going to involve. And around the world, there are similar kinds of things happening. And just call your service center in your area or call your sales manager in the area, and they can specifically describe what happens at those other service centers. What else, gentlemen? Tom or Tom?
So there was just a question. Could you talk about care during packing it up? Concerned about twisting the probe while actually putting it back into the case.
No, that's a great question. And so torsional twisting is what you're most concerned about, putting torque along the axial length of the insertion tube. And that's what you want to avoid. So when, and I'm talking about on one of our scopes, whether it's the XL products or the Mentor products, they all have reels in the cases. And so if you lay the system, meaning the display, down in the case and then straighten out the insertion tube and hold that insertion tube behind the camera and then walk back to the reel and start feeding that camera in, you won't get torsional twisting on that. However, I've seen people get it down to the last couple of feet and there's a big ball of insertion tube that's rolled up. They try to force it down into the reel, and that is going to put torsional strain along that insertion tube. So either A, pull the insertion tube back out, straighten out all of the twists so that it's just laying out naturally along the longitudinal axis, and then feed the camera back in the reel so that when you get to the end, it doesn't have that balled up kind of strain on the insertion tube. Or lift the display out of the case and unwind the torsion that's been placed on the insertion tube and lay it back down into the case. But either way, don't twist on it, meaning don't twist on the insertion tube to try to force it down in that reel when you have a coil of insertion tube that's balled up and won't go into it easily. That's a great question. Okay. I see people try to do it all the time.
Hey, Paul, okay. It's Tom. I have a question from Susan, and she's asking if you could please go over the point on not dislodging the pins in an optical tip adapter. And she's asking, is that when you're cleaning the inside of the tip?
Yes, exactly. So I'm still waiting for my screen share to come live, but since it hasn't, Susan, let me just push this slide back out because I want to see if you guys are looking at my inspecting and cleaning optical tips. Are you seeing that with the O-ring and the tip in the middle of the page?
Yes. Yep.
So, and then Tom, now that we're looking at this, please restate Susan's question.
Yeah.
It had to do.
Yep. So the question is, when you're cleaning an optical tip adapter, this would be a measurement tip. She's asking about the pins, and the question was about cleaning the pins and whether or not that, or it was actually about whether that was during cleaning and how you safely do that.
Yes. Good. Okay. So what you're looking at on my screen is the ID, or the proximal body of a 3D phase measuring lens. And those pins that are on the right, the pogo pins, if you will, that's what I'm calling them there, they don't need to be wiped down with anything. When you're cleaning the back side of this body, you're going to want to avoid those pins. And if you think that there's oil that's in the back side of that, let's talk about that separately. So the normal cleaning process on a 3D phase pin is to stay out of this cavity and only clean the threads, number one. Number two, if the image is blurred, meaning you're looking at the camera with a lens, any lens, clean the front side, clean the distal lens first. And then if it is still blurry, get a microscope or a 10x loop or some kind of a magnification instrument and look at that proximal lens and clean only that with a micro wipe, okay? As you're looking around in there, if you see there are oils or other contaminants inside of that body, you can put this entire assembly into a small cup of 70% isopropyl and swish and wiggle and cause it to rinse out, and then airflow it to dry the alcohol out of it. In most cases, that will take the contaminants out of there. If for some reason you've been working in, and this happens a lot in wind turbines, meaning it's exposed to, the lenses and cameras are exposed to oils that are not easily cleanable with alcohol, then you'd want to use that same dish soap method where you put a couple of drops of dish soap that profess to have degreasing capabilities and swish it in the soapy water take it out and put it in clean. It's best if you use distilled or some kind of filtered water, not standard tap faucet water, because you'll get the alkaline and hard water buildup over time. You could, but clean it with clean water, preferably distilled water, a couple of drops of dish soap, rinse it out, and then air dry it. So it's those pins that you want to stay away from. You don't want to wipe them down with any mechanical instrument. Just rinse them off if needed in the way I just described. And Tom, anything else?
Yeah, are you ready to take more questions, Paul?
Yes, sir. I'm still trying to get my live display to come up, Tom, but let's take another question or two while I'm playing with that technology.
Yeah, so I have a question from Mark. He's asking about 3D and or stereo measurement. What he's asking, and I'll take a crack at answering it, Paul, and then you could please add color as needed. So he's asking, to evaluate damage in a turbine engine, are there recurrent calibration requirements or periodic maintenance that would affect accuracy of measurement? And so, Mark, when we calibrate, which is required, the tip, the measurement tip, whether it's 3D stereo, traditional stereo, or 3D phase measurement, it has to be calibrated to the probe. And so we do that in the factory, whether it's being repaired or whether it's a new system. Once you receive the system, you'll note that there's a verification block that's with the system, and it's best practice to always use that verification block to verify the accuracy of the system. And you'll see that there's some little targets in there to allow you to do that very easily and in an automated way. As long as that is, if you follow that best practice and your measuring accuracy is within the tolerances of that block, there is no need to do any periodic maintenance there. If there's a calibration requirement, that would typically be if you're buying a new tip, new probe, or having some repair done. Paul, anything to add to that?
Tom, I think that's pretty clear and thorough.
Okay. I have another question. This is just a general comment. Paul, maybe you can help with this one and related to care and maintenance. Raphael says, I have frequent oil infiltration in my probe. And Raphael, it might be handy if you tell us what your typical application is, where you're getting this infiltration. But Paul, do you have any comments on how you might avoid oil infiltration in the probe?
Yeah, Tom, that's a great question, because there are inspection requirements where the camera is absolutely going to be exposed to liquids, whether it's oil or otherwise. And so my first thoughts are that something about the insertion tube is not watertight. It's easy to tell if there's damage by just taking a thin shop towel, lightly moistened with, I start with water. I use alcohol as a last resort if it's not coming clean. Put some water on a shop towel, start at the torsional relief section all the way back at the camera body, and walk your hand or slide it down with light pressure. Don't squeeze it, because you'll miss the nuance of any damage or fraying or anything that's on there. And walk your hand along the whole length of that insertion tube. If you feel kinks and dents, it could be that your insertion tube's leak tightness has been degraded from damage to the insertion tube. Similar kind of thing can happen out on the bending neck, and it's harder to tell. If there's no damage on the bending neck, usually, Raphael, the Viton sleeve inside is not damaged, unless it's been exposed to some chemicals that have caused it to degrade, and you wouldn't be able to see that. And then lastly, depending on which camera and optical tip adapters you have, Tom Ward, being the product manager for these optical tips and cameras in the past, we've gone off and employed or deployed, if you will, newer epoxies. Like if you're looking at that proximal lens, around that proximal lens is an epoxy bond that is holding the O-ring into the outer channel. And that epoxy can be eaten up by some lubricants. And inside the body of the optical adapter, there are lenslets that are epoxied in. So a lot of work's been done to get oil-resistant epoxies into those, and it just sounds like, I'm just reading the tea leaves here, that one of those has an issue that you're getting oil frequently into the inspection camera. I'm curious if this is on an application where a 3.9 millimeter camera may be better suited for the task. And Tom Ward, you want to tell us why that is? What's different about the 3.9 lensing versus the 4.0 millimeter lensing?
Yeah, thanks, Paul. And Raphael's gotten back and saying his application is in a gearbox, a wind turbine, which I suspected. So it also may be, and Raphael, if you want to have a more personalized, deeper conversation on this, we can connect offline here and talk through specifically what's going on, bring in our technical support experts, and probably give you even more detail here. But Paul, the question that you asked me is around the 3.9. That particular probe has a fixed camera system in the optical range of typical gearbox wind inspections that we do. And so there's no taking on a tip on or off there. You simply use the head optics on that probe. So it's difficult to get oil in there unless there's a damage situation. When using the 4 millimeter product, which is got a better optical system in it, that came to the market after the 3.9, you do need to use a tip optic, in this case, a black tip optic, a general tip optic, to have the same visual requirements or optical characteristics as the 3.9. So you'll have to screw that tip on. And sometimes what we find is it's easy to have a little bit of oil on your fingers, or it gets on the side of the tip, and then it can work its way inside and get between the inner body of the tip and the outer camera lens, and can create a situation where you have a smudgy image.
Great. Hey, Tom and Tom, we're getting close to the top of the hour. I'd like to take one more question and then close with some information about where people are going to be able to find this video that I will create and post for them to view. But any last question, Tom, that we can address with the callers?
No, I think we have some for the end that's a more general, not necessarily relevant to your specific topic for today, but I think you can have some forward references to the ongoing series here, and we can get them into them at the end.
Great. So Tom, thanks for helping out here. Folks, I regret that the live demo didn't work. However, there's always a plan. If you're an astronaut going to the moon, you better have some triple redundancy going on. And what I'm going to do is record live what I wanted to show you, and you'll find it posted on our Waygate Technologies YouTube channel. By the way, if you go there, you'll find a large number of learning videos on our products and on the capabilities that you may be using in the field. So look for that video. I'll get it posted here over the next couple of days. And two, be sure and look on your resource panel if you want one of us or one of my colleagues to reach out to you and do a live distance demo with you, or if the precautions and proper precautions are taken, we are considered an essential business, and we will help you get out of a jam as long as both parties are all following the proper COVID protocols on site. Our salespeople are also making live visits. So if you would like either a virtual or a live demo, please let us know. And then if there's something we didn't answer and you want us to get back to you directly, just post that in there and say, yes, I'm looking for you to follow up. And like Tom Ward said, have a more personal conversation about it. So with that, I'm going to wrap the call. I'm going to invite you to join the other 3 webinars that we have coming up over the next week. And I look forward to seeing you on another learning event, either here or live at the Waygate Inspection Academy. Thank you.